Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! You're listening to the podcast where math is figureoutable. I'm Pam Harris.
And I'm Kim Montague.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So a few weeks ago, we talked about place value, right? Noticing some
episode
patterns.
100, place value.
Oh, yeah.
Yeah.
And so those were about when multiplying by 10, just noticing patterns that emerge. Today, we're going to talk about a subtle nuance in solving multiplication problems, about becoming more sophisticated, a more sophisticated relationship that we want to nudge students towards.
And I'm going to say this is something I think we talk about. We help students progress. We help them develop this relationship. But I'm not sure I've seen this anywhere else. So this is a little subtle, but so cool and so powerful. And let's get right at an example. So if I were to ask a relative beginning, I shouldn't say beginning multiplier, but someone who's learning maybe double digit multiplication, bigger number. So not like single digit, like what does multiplication mean? But we're kind of getting to maybe problems like 40 times 17. So 40 times 17. If I were to, so maybe pause the podcast for a second. You figure out, how would you figure 40 times 17? Get a handle on the relationships a little bit. So come on back. So if we were to hand that to a student who's just thinking about these sort of bigger numbers and they're kind of making sense of 40 times 17, often we would find that a first go-to strategy for students might be something like, or would be something like, okay, I need 40 17s. So I'm going to think about, 10. That's why we just brought up this idea of multiplying by 10. 10 17. So a student might say, I know 10 17s is 170, but I need 40 of them. So 20 17s, they would double the 170 to get 340, double 170 to get 340. So now they have 20 17s, and then they might think about doubling the 20 17s, double that 340 to get 680. And now they have 40 17s. So they might think about that 40 anythings really as 10 of them, double that to get 20 of them, and double that to get 40 of them, whatever that is. And that's it's fantastic. We want students to be thinking about, okay, if I'm thinking about 40 of these guys, whoa, how can I get up there? We might have students thinking more additively, but when they're thinking more multiplicatively, which is what we're heading towards, that's brilliant. We want kids kind of thinking about, like I'm repeating myself, but 40 things, 10 of them, then I could kind of double up to get 40 of them. Or maybe even once I had 20, I could add the 20 and 20 to get 40. And in some way, they're kind of using that 10 in a helpful way.
Right.
So I remember the day, Kim. I remember the day when I realized my brain was starting to make a shift. That for maybe a hot minute, I had been shifting and it felt like a sophistication shift. It felt like I was doing something more sophisticated. That when I began to look at a problem like 40 times 17, I began to say to myself, I'm going to think about 4 17s, and then
Mm-hmm.
I'm going to scale that times 10. I
Right.
began to see 40 less as 10 doubled to 20 doubled to 40, and more multiplicative as 4 times 10. And if I
Yeah.
could think about 40 as 4 times 10, then I literally, and maybe it was because I was dealing with ratio tables so often, but if I were to do 40 times 17 today, I would write down 117, 1 to 17, a ratio table with 1 to 17. And then I would think about 2 17s as 34. And then I
Mm-hmm.
would think about 4 17s as 68. And then I would scale 4 to 40 times 10, and then 68 times 10 to get 680.
Yeah. That's pretty interesting that you can remember exactly when that happens.
Oh my gosh, I remember the day. I remember
Yeah.
thinking, that's more sophisticated.
Yeah.
Like, I'm seeing so many kids use, and I had, like, really, like, kind of finding the 10 and then multiplying up from there, instead of multiplying up and then scaling by 10.
Yeah.
And I found that kind of interesting. So
Yeah.
if we were to use the associative property to kind of look at that, we might think about that 40 times 17. Well, we might think about it in more of a distributed property way, where it's sort of like 10 times 17, and then maybe add that to another 10, or maybe then, yeah, maybe if I was to stay with the associative property, 10 times 17 is kind of is in parentheses and then times 4, versus 4 times 17 in parentheses, then times 10.
Mm-hmm.
Is that a way to write that? Do you agree with that, Kim?
I didn't write it down. I'm sorry.
It's okay.
Say it again.
If I'm thinking about 40 times 17, the first
Uh-huh.
way, the less sophisticated way, I
Uh-huh.
wonder if I could write that as 10 times 17
Mm-hmm.
times 4.
Mm-hmm.
It's like I'm thinking about the 10 times 17, I'm finding that 170, and then I'm messing with that to get 4 of those groups. I might
Mm-hmm.
do that by doubling to get 20 of them, and then doubling again, but I'm
Mm-hmm.
really focused on the 10 times 17, and then I'm
Sure.
focused on getting 4 of those groups somehow.
Yeah.
Versus what we're kind of want to nudge kids towards is thinking about 40 times 17 as 4 times 17, that's in parentheses,
Mm-hmm.
then, and find that, then scale that times 10.
Can I actually tell you about something that happened? So
Yeah.
when Cooper, my youngest, was in third grade, he started towards the very end of the year. He was starting to dabble in a little bit of, I don't know if it was 2-digit multiplication or 2-digit by 2-digit,
Mm-hmm.
but certainly some larger multiplication problems, multi-digit. And I remember he had some problem that was probably something like, I don't know, 70 times 12, right? And
Mm-hmm.
I was like, oh, okay. So this is going to be, he was comfortable with the ratio table. And I thought, okay, cool. You're going to chunk your way up there for a while. It's going to take you a minute
To get 70,
to get
70 of
70, right?
those.
That's a lot of 12s.
Yeah.
And so I was prepared to sit next to him and kind of talk to him about what pieces do you know and work his way there. And I remember being so
Let
fascinated.
before you go on to what he did, you were prepared to have him do something like 10
Oh,
times
like 10
12.
times 12, 20 times 12, 40 times 12, add some groups of tens together, exactly like you mentioned.
Mm-hmm.
Um, just groups of tens building up to 70 12s.
Mm-hmm.
And he didn't. And I was not prepared for that. What he said was, "Oh, it's like 7 times 12 times 10." And I thought, how in the world do you know that? And we have he was so confident about his understanding about 70 was 7 tens or 7 times 10. He was thinking multiplicatively about 70 to begin with.
Mm-hmm.
That then when you said times 12, he had an understanding about saying that's the same as or equivalent to 7 times 12, scale that by times 10. And I wasn't prepared for that. I got to be honest with you. I was like, are you sure you know that? And
So we
Um,
had similar moments. It was in my
yes.
brain. I was recognizing what my brain was doing, and you were recognizing
Yeah.
what Cooper's brain was doing. You were like, man, like that's,
Yeah.
and in that moment, both of us, I think, had this sort of like aha that that's more multiplicative.
Sure.
And that is part of our goal. We want not only to move students from counting strategies to additive reasoning to multiplicative reasoning, but in multiplicative reasoning, we want to also get more multiplicative in our reasoning,
Yeah.
and that could be a goal.
Yeah.
So, for example, you might think about problems like, I was talking about 40 times 17 earlier. So, because we have those numbers floating around, I'm going to kind of go on that theme. What if we were to think about 42 times 17? So, I might expect a beginning student to do 10 17s, 20 17s, 40 17s. Then a completely new problem. Think about, okay, now I need, if it's 42 17s, completely new problem. Now I got to find two 17s, not recognizing that they already had 20 17s. They could
Mhm.
use that to help them scale down, like divide by 10 to find the two 17s. 20
Mhm.
17s is 340. Then two 17s would have to be 34. Not even thinking about that, there would be a whole new problem. And then they would add, once they found the two 17s, they would add that back to get the 42. Now I might be nudging students who really own that. We want to start there. That's going to be their first sort of thing to do. We want to start there. But then I want to nudge students using problem strings to help them think about, ooh, could I, so if I was to solve 42 times 17, use thinking about 42, like I might think about 1742s. But if I was thinking about 42 17s, now I might go, okay, 1 to 17, two 17s is 34, four 17s is 68. Therefore, 40 17s. Now, what's funny, Kim, is in my ratio table where I had the 4 to 68, I'm just
Mhm.
tacking on a 0 to make it 40
Mhm.
to 680.
Yeah.
And I'm going to give my daughter credit for that one. I was watching my daughter solve problems, and she would literally, if she knew she was headed for 40, she would find two, four, and then turn that four into a 40. And whatever that was, the 4 to 68 became 40 to 680. And then so now my ratio table on my paper literally is 1 to 17, 2 to 36, 34. I can read my writing. 2 to 34, 40 to
Sure.
680. And then I just add the 40 and the 2 together to get the 42. And then the corresponding, I hadn't done that yet. Is that 714? Uh-huh. I can add live there to get the 42 17s. So then when I figured that out, then I got excited. And then I was like, whoa, like so 44 17s. Once you found the four, you've got the 40, you just add it back to the four, and then you've got 44. Then I got excited to do things like 88 17s because I could find the 8 17s. Then I would have the 80
Mhm.
17s, and I would just have
Mhm.
to add it to the 8
Mhm.
17s. Like lots of ways of finding the small number first, find the 8 17s, and bam, just scale that up to
Yeah.
the 80 17s. Became a way that was more multiplicative and a way that I could sort of mess with smaller numbers first before I had to mess with the bigger numbers. Does that make sense when I say that, Kim? That I was kind of messing, like if you're finding 10 17s and doubling that to get 20 17s, you're doubling 170,
Right.
right? And
Right.
then now I've got 20 17s is 340. To get the 40, now you're doubling 340. You're messing with these big numbers
It almost
versus, oh, go ahead, what?
it almost feels like what you're about to say, the sticking with the single digits, it almost feels like a little bit more of a pre-planning. Like you know you're going to 40, but you want to stay in 1, 2, 4,
Mm,
40. It's
it's the
almost like
anticipatory thinking.
it's like you're
Yeah.
considering where you're heading.
And so that is more sophisticated, right?
Right.
You're not just kind of, okay, I need 40. Well, let's find some chunks I know and start working up there.
Right.
Instead, you're kind of anticipating, well, if I need 40, bam, if I have four, I can scale times 10 to get the 40. It's really nice. Thanks for
Well,
popping that in there.
and I think that what you said is true. Like we're not dogging the 10 groups, 20 groups, 40 groups.
No, that's necessary.
It's
That we have to start
necessary,
there.
right?
Yeah.
But then we
Yeah.
can start considering and kind of lobbing out, well, what if you had 40? Could you have 1, 2, 4, 40? Would that, just throwing out the suggestion that that might be a thing to consider and see who
Mhm.
takes that up?
And how do we throw that out? I would suggest it would be a problem string.
Problem
And the
string.
problem string
Yeah.
would literally be what we just did. Find 2 of them, find 4 of them, find 40 of them.
Mhm.
And then let kids realize, oh, I can, from the 4, I can scale to get the 40. Huh, that's a thing.
Yeah. Yeah.
Huh. So this idea of when you do kind of the less sophisticated, less anticipatory thinking strategy of kind of just working up, and so you end up working with these bigger numbers, also plays out in the 5 is half a 10 strategy,
Mhm.
because there's this cool extension of how we can use a tweak on the 5 is half a 10 strategy that lets us deal with smaller numbers first and then scale. So for example, if we were dealing with a problem like 50 times 15, that might not have been my smartest number choice, since now I'm dealing all these 15 sounding things. So 50 times 15, if I was doing that problem, we might expect a less sophisticated learner to do exactly what we just said, where they might find 10 15s and then double that to get 20 15s, double that to get 40 15s, and then add back the 10 15s, so 40 and 10 to get the 50 15s. We might expect
Mhm.
a beginning sort of bigger
Chunking
number
stuff. Yeah.
multiplier to
Yeah.
mess with that. But then we want to deal with the 5 is half a 10 strategy, which is also has an analog of 50 is half of 100. And so to find 50 15s, we might nudge students to find 100 15s. Now that I know that that's 1,500, then I can think about 50 15s as half of that. And so half of
Mhm.
1,500 is 750. And bam, I can use 5 as half a 10 to help me think about 50 15s. But the analog here of
Mhm.
those are big numbers, right? I'm thinking about 100 15s, and then I'm cutting that in half to get 50 15s. The analog of using the smaller numbers and then scaling would
Mhm.
be, could I think about 10 15s is 150 to get 5 15s. So if 10 15s is 150, then 5 15s is half of 150 is 75. Now scale that up to get 50 15s. I'm scaling up the 75 times 10 to get 750.
Yeah.
But then there's even a third analog where we can even deal with smaller numbers. And this is really the middle school move. This is where I want to move sort of in 5th and 6th grade, where to think, again, remember our original problem is 50 times 15. So to find 50 15s, could I find half of 15 or 0.5, half of 15? What? Half of 15? Well, yeah, because 0.5 is going to eventually, again, this anticipatory thinking, if I need 50 of them, well, I could find 10 of them to get 5, but can I just find 0.5 of them, half of 15, and then scale that 0.5 up to 50? So half of
Yeah.
15 is that 7.5, which therefore at 5 15s would be 75, which therefore 50 15s would be 750. So that's an analog of I can kind of deal with the smaller numbers first and then scale up. And that is more both multiplicative thinking and
Mhm.
more anticipatory thinking, where we kind of
Yep.
see the end from the beginning and kind of have a roadmap of how to get there, which is more sophisticated. Cool, right?
It is really cool. Yep.
It's so cool. So we wanted to do an episode today to kind of help you in on this subtle, sophisticated move that we want to help students make. And what are the best ways to do that? Problem strings that showcase these relationships and that help students realize, oh, that's a thing. And then we can bring that in to our work. Super cool. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.